So hello everyone. So in this lecture we are going to see the congestion control mechanism. So this is a part of it. So back then we had seen this slow start phase, one of the phase of congestion control mechanism, and congestion avoidance phase. So what happens in slow start phase is that it will start with 1 MSS, okay, and it will grow exponentially. See, it's not always that this slow start phase will start with 1 MSS, okay. It depends upon implementation to implementation. It may even start with 2 MSS, okay. So it depends upon implementation. So whenever you encounter such questions, be careful. You have to be careful. You have to start with 2 MSS. If it is mentioned that it is start with 2 MSS, then definitely you have to start with 2 MSS. Okay, so it depends upon implementation to implementation. Okay, then it will grow exponentially, and once it grow exponentially, then it will hit the threshold. Once it hit the threshold, okay, threshold is nothing, whatever the receiver size is divided by 2, then it is threshold. Once it hit the threshold, then it will grow linearly. Okay, so our congestion window size will grow linearly, 9, 10, 11, like this. And after that, it will reach to the maximum sender size, maximum receiver size. Okay, then once it reach to the maximum receiver buffer size, then it will keep on sending that much number of segments. So this is what we have seen. But in congestion control mechanism, there are one more phase is there, third phase, which is called congestion detection phase. So two phase we had seen, first slow start phase and congestion avoidance phase. There is one more phase is that which is called congestion detection phase. Okay. So this is the graph for congestion control mechanism. You can see that it start with 1 MSS, right? Then it will grow. It will start with slow start phase at the beginning. So then 1 MSS, then 2 raised to power 1, which is 2, then 2 raised to power 2, right? Then 2 raised to power 3, then like this it will go on, right? 2 raised to power 1 is how much? 2, 4, 8, right? Then once it hit the threshold, then after that, so for example this is where it had hit the threshold, then after that it will move, it will increase linearly, like 9, 10, for example threshold is 8, consider 11, 12, 13, 14, 15, 16, and after that when it reaches to the maximum size, then it will keep on sending the same 16, like maximum receiver side. Once it hit, then it will keep on sending 16, 16, 16 constantly, right? So this phase is called slow start phase, this phase is called congestion avoidance phase, and this is where the maximum receiver capacity is met, right? So this is what we have seen till now. Fine. Now we will see detection phase. So here we can see that congestion control mechanism has 3 phases: slow start phase, congestion avoidance, then next is congestion detection phase. So before starting into congestion detection phase, what I will do is I will assume that at least I will send 4 segments at a time. At least I will send 4 segments at a time, and I will receive the acknowledgement for that all the 4 segments. Okay, that is my assumption. Okay. See, we can send 1 segments, 2 segments, 3 segments, but for that these algorithms now, so that this algorithm will work smoothly without any problem. So I am assuming that at least 4 segments it will send at a time, and I will receive an acknowledgement for that particular 4 segments. With this assumption, we will see there is 2 cases are there for congestion detection. So there are 2 ways we can detect a congestion, that is with timeout, and second is with 3 duplicate acknowledgement. Okay, whenever the timeout occurs, then we can consider that congestion is very severe. Okay, we have to take some immediate action. Or if second is when 3 duplicate acknowledgement happens, then we can consider that congestion is mild. Okay, it's not that severe. Okay, so these are 2 ways we can identify whether the congestion occurs or not. Fine. So what do I mean by timeout occurs, right? So in congestion detection phase, what is the timeout occurs? Timeout occurs means whenever we have a timeout occurs, it means, for example, for this particular packet there would be some timeout, right? Okay, I will draw like this. There is some timeout, right? For this also there would be some timeout, right? So whenever there is a timeout occurs, see what I mean by timeout occurs is that whenever we have timeout occurs, it means that one packet is lost, after that all the packets are lost. That means if this packet is lost, after that all the packets are lost. This is called timeout occurs. Okay, if such situation, say that means you are not receiving acknowledgement for any of the packets. You are not receiving an acknowledgement for any of the packets. That means you can consider this particular congestion is very severe. Okay. And the second is 3 duplicate acknowledgement. What is 3 duplicate acknowledgement? Whenever we get 3 duplicate acknowledgement, then it means that sending many packets and one packet is lost, after that some packets are received. But 3 duplicate packets. Okay, sender will send one packet. Sender will send one packet. Fine, sender will send one packet and it is lost. Okay, like this sender will send 4 packages, then one of the packet will be lost, and after that all the 3 packets is received. Okay, this is 3 duplicate packets. So what I mean is sender will send many packets, and out of that one of the packet is lost, and after that some packets are received. Okay, that is 3 duplicates. See, when you for example in this case, see you have sent 4 packets and one packet is lost, right? After that 3 packets are received. 3 packets are received. So if you receive 3 packets, that means you will get 3 acknowledgements, right? So this is what I am talking about, 3 duplicate acknowledgements. Okay, so when this case happens, when 3 duplicate acknowledgement when you receive, then you can consider that the congestion occurs is mild conversion. Okay, it's not a severe, it's a mild. Let's see what will happen when the congestion in congestion detection phase, when there is a timeout and there is a 3 duplicate acknowledgement. Okay, so for example in congestion detection phase, when there is a timeout, okay, that means the congestion is severe, right? At that time what our algorithm will do is it will take a threshold, it will create a new threshold. How it will create? It will take a half of the whatever the current congestion window is. Okay, it will take half of the current congestion window. This is nothing but current congestion window. Current congestion window. This is nothing but current congestion window. So it will take a half of the current congestion window and it will form a new threshold. Okay, after that it will enter into slow start phase. Okay, and whenever there is a 3 duplicate packets, then again it will form a new threshold by making a half of current congestion window. Whatever the current congestion window is, take a half of it and form a new threshold. Okay, and after that the algorithm enters into congestion avoidance phase. Okay, whenever there is a timeout timer, after forming a new threshold, it will enter into slow start phase, and when there are 3 duplicate acknowledgement, then new threshold will be formed and the algorithm will get into a congestion avoidance phase. Okay, so remember this point. Now we will solve one problem. With that you will understand very properly. Okay, now let us assume this is our question, that we have receiver size as 64 kb, okay, MSS as 1 kb. So I told you that whenever we have something in kb, we will assume 1 kb equal to 1 MSS. So we will try to convert everything into MSS. So receiver window size I convert into 64 MSS, 1 kb as 1 MSS. Then we will calculate threshold at the beginning. What would be threshold? Receiver divided by 2. Receiver window size divided by 2, which is 32 kb, that is 32 MSS, right? So at the beginning we will start with 1 MSS, right? We will start with 1 MSS. So we will start with 1 MSS, then 2. Okay, so at the beginning we are at slow start phase, so it will exponentially grow. So 1, 2, then 4, then 8, okay, then 8 means after that 16 means 2 raised to the, you can see 2 raised to the 0, 2 raised to the 1, 2 raised to the 2, then 2 raised to the 3, then 2 raised to the 4, and after that what? After that 2 raised to power 5, which is 32. Okay, now at 32 we had hit the threshold. We can see we had reached to threshold, right? Now what will happen? So till this phase it was congestion slow start phase. It was slow start phase. Then after that we hit the threshold. Then after that what will happen? It will grow linearly. After that it will grow linearly. 32, then 33, then 34, then 35, right? This way it will start growing unless and until reach the full capacity. But now assume. So assume, see, we are in congestion. See, when we hit the threshold, we will enter into a congestion avoidance phase, right? And after in congestion avoidance phase, we'll start growing in a linear phase, right? Then suddenly there would be some timeout. Now consider scenario, suddenly there would be timeout. Now assume there is some, see, this is a congestion avoidance phase, right? So at this, any of these phases, there can be a congestion, and this algorithm can detect congestion at any of these phases. Here we are at congestion slow start phase, then here we are at congestion avoidance phase, right? So any of this phase, we can detect, this algorithm can detect a congestion. Now assume when it is growing linearly, suddenly there would be some congestion. Okay, so assume we are at, for example, we are at 34th. When it's sending a 34 segments, there is timeout occurs. What does it mean? That sender had sent 34 segments and one segment is lost. After that, all the segment is lost. That is the meaning of timeout occur. So after sending 34 segments, one segment is lost. After that, all the segment is lost. Okay, so that means timeout will occur, right? So that means this situation is severe. This is congestion. That means this congestion is very severe. Okay, so how our algorithm will at this time, how our algorithm will resolve the problem? Then what I told you, whenever there is a timeout at congestion detection, what it will do? It will see, we can see here, whenever there is a timeout, then there will be new threshold. Okay, that which is half of the current congestion window, then it will enter into the slow start phase. So whenever there is a timeout, there will be a new threshold and it will enter into the, it will calculate new threshold and it will enter into a slow start phase. Okay, so we can see that. So here also it will calculate the new threshold. What would be the new threshold here? The new threshold will be, new threshold will be how much? New threshold will be 34 divided by 2, which is nothing but 17, right? Then after that it will enter into slow start phase. Okay, this was congestion avoidance phase. Okay, now it will, after calculating a new threshold, or new threshold is this, it will enter into a slow start phase. So slow start phase means it will start with 1 MSS itself, 1, then 2, okay, exponentially growth, then 4, then 8, unless until it reaches to the new threshold. Then after that 8, 16. Okay. Now after reaching 16, according to the slow start phase, we have to go to 32 exponential growth, right? But we will not go to 32. We will send only 17 segments because we are reached to our threshold. Okay. So don't write 32 here. Okay. It will be 17 because our threshold was 17. So we have to go till threshold. So slow start will start from 1 MSS and go up to the threshold. The threshold is 17. So after 16 it will go to 17. It will start sending 17 segments. And after reaching to the threshold, see, we had already reached to the threshold, and after that it will get into a congestion avoidance phase again, means linear growth. This was slow start phase, then again it will enter into the congestion avoidance, that is linear growth. That means 18, then 19, then 20, okay, like this. Now assume at 20 we have a 3 duplicate acknowledgement. At 20 we have a 3 duplicate acknowledgement. Okay, means when you are sending a 20 packet, so that means, what is this means here, that we had sent 20 segments, okay, and one of the segment is lost, and after that 3 of the segments we have received it. Okay, one of the segment is lost and at least we got 3 segments, that means we got 3 acknowledgement back. So this is through 3 duplicate acknowledgement, and in this case congestion is detected and this congestion is mild. Okay, so congestion is not severe but it's mild congestion. Fine. Now, so when the congestion is detected, when 3 duplicate acknowledgement is received, then what will be happen? At this time congestion is detected, right? Then new threshold will be created. We can see here, see, there would be new threshold. See, we will calculate a new threshold and the algorithm will enter into the congestion avoidance phase. So here also, whatever the current window size, our current window size is 20, right? We will calculate a new threshold. What would be the new threshold now? New threshold will be 20 divided by 2, which is 10. That is our new threshold. Then after that we will enter into congestion avoidance phase. See, then we will start from 10 itself. Whatever the new threshold is, we will start it, and after that we will get into linear growth, then 11, then 12, okay, so on. So remember this, whenever see, we are in slow start phase, okay, and suddenly we hit the threshold, after that it will get into a linear phase, right? Then what happens, suddenly we are in a linear growth, then after 20 it will be 21, 22, 23, like this, okay. But what I said now, suddenly we hit into a through duplicate, suddenly there is a mild congestion detection, that is 3 duplicate acknowledgement. Then what our algorithm will do is, our algorithm will calculate the new threshold, okay, and that threshold is 10. Then instead of 21, 22, 23, it will start from that new threshold, that is 10. Then it will grow linearly. Instead of 21, 22, 23, then it will start from new threshold 10, 11, 12, and it will start linear grow. Okay, like this it will start growing linearly. Fine. Okay. Now assume while sending a 12th segment, means 12 segments, there is a timer here. Timer occurs. That means congestion is detected and it's severe case. Okay, then what will happen? Our algorithm will enter into a slow start phase. Slow start phase means it will start from 1 MSS. See, this 1 MSS, it's depend upon implementation. I again telling you, if in question it is maintained that you have to start for 2 MSS, then start from 2 MSS. It depends upon implementation. Here we are assuming that it is started from 1 MSS. Okay, so read, in such situation, read the question properly and continue it. So timeout occurs at when you are sending a 12 segments. That means you send 1 segment and after that all the 11 segments are lost. Right, now what will happen? Our algorithm will enter into a slow start phase. Then it will start from 1 itself, right? Then 2, then 4. Okay, so I told you, sorry. So at this time, see, whenever the timer occurs, it will calculate the new threshold also. Okay, I forgot that part. It will calculate new threshold. The new threshold will be what? 6. Right, the new threshold will be 12 divided by 2. The current congestion window size is 12. So it will be 12 divided by 2, which is 6. So it will start from, it will start a slow start phase and it will go till, it will grow exponentially till 6. Right. So slow start phase starts in 1, 2, 4, then after is 8, right? But our threshold is 6, so we will not go to 8, we will directly jump to 6 only. Okay, because our threshold is 6, right? Then we will stop here. Then slow start phase is over. Till here the slow start phase is over. Then algorithm directly enter into a congestion avoidance phase. Okay, so that is a linear growth. That means it will start 7, fine, it will end 7, then 8 like this. Okay, now assume at 8 there is a 3 duplicate acknowledgement there. Then what will happen? It will calculate the threshold. Okay, that is 8 divided by 2, which is 4. Then at 3 duplicate package, right? So this is a 3 duplicate. So when there is a 3 duplicate acknowledgement, it will calculate the new threshold, that is 4. Okay, then it will enter into a congestion avoidance phase and it will grow linearly, but it will start from 4. Linearly means it will not directly start from 9, it will start from 4 itself. So 4, then 5, okay, then 6, then 7, then 8, then 9, okay, then 10. So it will go till the maximum receiver size. What was the maximum receiver size? 64 MSS. Okay, so it will go till maximum receiver size, that is 64 MSS. So it will go till 64 MSS, and once it reaches to 64 MSS, then it will keep on sending the packet at full capacity, 64, 64, 64 like this, so on. Okay, so this is what happens, right? So hope you understood this solution. Okay, so this is what happens exactly in congestion detection phases. Okay, there is a timeout occurs, there is a duplicate. Whenever there is a timeout occurs, then we will calculate the threshold and it will enter into the slow start phase, right? You can see here. Then it will go till whatever the threshold is. Then after that it will again enter into a congestion avoidance phase, and in between if you get any 3 duplicate acknowledgement, then again the threshold will be calculated, and after the threshold it will, from the threshold itself it will grow linearly. This is where you have to be careful. Okay, it will start from threshold itself. Okay, don't directly from 20 write 21, 22, 23. Okay, fine. Then again if timeout occurs, then it will get into slow start phase. Okay, till the threshold. Start from slow start phase and grow exponentially till the threshold. Okay, so now again after when it gets any 3 duplicate acknowledgement, then again it will calculate the threshold and will grow in linearly till it reach the full capacity of the receiver window size. Okay, after it reaches the full capacity of receiver window size, then after that it will keep on sending that much amount of packet. Okay, so it will keep on sending 64 segments at a time to the network, right? Because now the network is stabilized. Hope you understood all the solution. Okay, so be careful. If in exam it is mentioned that it starts with 2 MSS, then you have to start with 2 MSS instead of 1 MSS. Okay, so it depend upon implementation in place. Slow start phase, there is no hard and fast rule that it has to start with 1 MSS. Okay, so these are the points you have to be careful while solving the question. Okay.